Hello. I'm gonna explain my fixed system since it's the only thing that really interesting about this. It might be helpful, and I will forget how to do this anyway, since it's gonna be and anyway. So how to do this? And this is all one Niagara system. How to do this? Uh, we have this actor that has this experience manager Niagara system, and this is asset. On the start, we are setting some variable of object to, so the system would have a reference to player, and we reset some variables for counting how many we spawned, and for array that contains positions and encoded colors of these particles, and we set some timer for Niagara parameter collection update. But this is basically just for player interaction, so I'm not gonna explain this a lot. We don't need Niagara parameter collection for the basic idea of one Niagara system. So the main, I already explained this in the other tutorial about runtime spawn new particles in the same Niagara system. So this is expand this idea. So for example, we have some event that we can call multiple times in one tick, and for this we want to update Niagara system only once in one tick. This is why we have this variable send, and also we want to collect how many we need to spawn, or it's better to say this is how many we are spawning from the start. So it's the 0 in the start, and when we spawn new particles, like it hits one enemy, and it's gonna call this event once, then it's gonna hit a second enemy, it's gonna hit twice. It's hitting when it basically when it hits enemy, it's calling this event. So every time it is increasing this variable and adding in this array variable new locations and encoded color like this, and also some different location of by z axis based on the color, so it's not gonna flicker by overlapping particles. So on the event tick, if length of this array is greater than 0, then we check do we need to send information to our Niagara system, and if we need, then we set static array length that is basically not current length but past. So it's just the way to compare values later to understand what order of spawned particles. We said how many we need to spawn. We need to spawn new ones, and also, of course, we set this user parameter vector for structure Niagara. Then let's dive into Niagara. As I did in the last tutorial, we have this emitter for spamming, for triggering new particles. So it has this simple idea of counting new particles that has to be spammed. So these variables and this variable. So this is pretty simple. When we need to spam new particles, we increase this parameter, spawner particle count, then it compare it to current parameter order by not really comparing, just subtracting it, since we anyway will need the number of particles that need to be spammed. So for example, if it start, it's gonna be 0 order and 0 spawning particle count. Then we hit 5 enemies in one tick. It's gonna be spawner particle count 5, the order 0. 5 minus 0 is gonna be 5, and spawn count not equals 0, so we're gonna spam and use max 5. So then create spam info. And after this, we update the order parameter by this. So since it's gonna be 0, we're not gonna spam new ones. And we use this emitter only for updating, like not updating, like for triggering. We could use their locations, but we don't need this. We only need to trigger for next emitter, in which first of all we use GPU fixed bounds for optimizations reasons, and this spawner emitter has to be once infinite, since system is once infinite. No, system is not infinite, but emitters has to be infinite, so system not gonna die. And this emitter is also once infinite. And then we have this custom module that I created from this Niagara module, spawning particles from other emitter. So this is pretty simple. All we need to do this is just get how many new particles was spammed in the spawner emitter to trigger spam new particles in this emitter. And then we just really calculating and doing nothing, since we don't need to do much. And this clamp is very stupid, but it was in the original. And after the clamp, we set in this spam info. And all this do just spams, like if we need to spam in one tick from hitting enemies 5 times, we need to spam 250 particles, since we spammed 50 for each spawner particle. Then we are using this module that I also created from sampled particles from other emitter, called burst particles, and we don't need to set anything using this module that it can afford. All we need to set is basic parameter spawner ID. So you can spam different counts of particles, but it's going to be more complex setup. So it's much easier to spam equal count of particles for each trigger, and for this instance it's 50. So first trigger particle is from 0 to 49, a unique ID, and of course it requires persistent ID. So then from 50 to 99, and this is gonna be a second spawner ID, index, and so on. And this is just to maintain order of spawner ID. Then we use user variables, location and color vector for array. In this custom Scratch module, in which we use the code color to set it in set position, and also check if it's valid. So for that we're using spawner ID and alt array length that we are setting here, static array length. And this is alt because on the next tick after what we sent, if we don't need to send, we are updating this variable, so it's gonna be equal for tick when we send, it's gonna be equal 0, and we know that we spawned this 5 particles, so it's gonna be 0 minus 0 0, 1 minus 0 1, and so from 0 to 4, since it's 5 particles. And for the next time, the next tick, if we don't need to send this, we're resetting this to 5. And then here we're gonna, like, if we again need to spawn new 5 particles, it's gonna be like 6 minus 5, for example. It's gonna be 1, and 2, and 3, 4, and so on. And since we are updating this array, so we need to reset this way, this index, to maintain right order, and set position and color. And that's all. Then we set spawner position to shape location, and calculating random velocity, and little words about interaction with player. For that we have object user variable that we set in the reference to actor of player that we used in this module to send data to player when it collides to the particles. Since I have simple shapes like circles, I can calculate this variable collided inside my module, custom module, of course. Also there is some attraction velocity, but this is different. So if distance from player to the particles is less than radius input variable, then it is collided. Simple like that. So it's gonna export data to the actor, and then it's gonna kill these particles. And since I started explaining about exporting data to the player, for that you can enable in your player class settings, implemented interface, add a search for this Niagara particle callback handler, and then you can be able to use this event receive particle data, which is gonna take particle data array. Also, this, and this is also you need to implement some batch method to not update particles for each get particle, but collect it in some function and then update. And this is how it's done. I hope it was enough. It's not very flexible setup, but it is, I think, kinda helpful. I'm sure you can do this better.